Find the GCD, greatest common divisor of 57970 and 10353. And the second question says that using your answer in 1, express the two integers as a linear combination of their GCD. Now, the first thing you need to note is GCD means greatest common divisor, and basically it means that we want to find the highest numbers that can divide these two things without leaving a remainder. So we are going to be using the algorithm to show that. So we want to find the GCD of 57970 and 10353. This is what we are looking for. The greatest number, the highest number that can divide the two integers. So look at how we go about the algorithm. You will pick the highest number, 57970. Look at what will happen. You will go to your rough sheet, 57970. You will divide this. Let's call this place the rough sheet. You will do 57970 divide 10353. So when you do that, you will see that it can go 5 times and there will be a remainder 6205. The reason is because if you do 5 multiplied by 10353, the answer will be 51765. And when you subtract that from 57970, the answer will be 6205. So that means that, look at the way I'm going to write it. 57970 is equal to 5 multiplied by 1010353 plus the remainder 6205. So basically this is what you will be doing. Pick the highest number, divide by the smaller number. The answer, it can go 5 times, remainder 6205. So if you do 5 multiplied by 10353 plus 6025, the answer will give you 57,970. Now after that, look at what will happen next. You will now take this one. You see that 10353. That is how the algorithm goes. You will divide with the remainder. I have 10353 divided by the remainder 6205. So actually when you do that, the answer will be 1. It can only go once, and the remainder, if you use your calculator, 10353 divided by 6205, you will see that 6,205 can go in 10,353 once, and the remainder will be 4,148. That is what the remainder will be. So what will happen is that this will give me 1 multiplied by 6205 plus 4148. That is what I'm going to have. So you will continue like that actually till you get to 0. You continue like that till you get to 0 or till you get to 1. Again, what is in this bracket? You will bring it here. 6205 is equal to, again you will come to your rough sheet, 6205 divided by 4148. Obviously it can only go once, and the remainder will be 2057. This means that I have 1 multiplied by 4148 plus 2057. So the idea is that you will start from the highest number, the bigger number, divided by the smaller one. So you will write it this way. It's called Euclidean algorithm. Do you understand? Or the algorithm of division. So that is what we have. So 5790 is equal to this. Now you will now take what is in that bracket. I mean, after that you take the smaller number divided by the remainder. I will continue this way till my remainder is 1 or till my remainder is 0. So look at what will happen next. This is 4148 4148. You see, that's what is in the bracket. So I'll do 4148 divided by the remainder 2057. So this will actually give me 2 and the remainder will be 34. 2 multiplied by 2057. You see the way I'm writing it, please take note of that. Plus 34. What is here? 2057 is equal to, I'll do again 2057 divided by the remainder 34. When I do that, the answer is 60 remainder 17. So this means that I have 60 multiplied by 34 plus 17. What is in the bracket? 34 is equal to, I will say 34 now divided by the remainder 17. That's 2 remainder 0. So this means 2 times 17 plus 0. So since I have 0 as my remainder, I will stop here. So therefore, the truth of the matter and the matter of the truth is that the GCD, greatest common divisor of the question 57970 and 10353 is equal to, now how will you know the answer? The answer is the last remainder before 0. You know, this is 0, the last remainder is 0, so the remainder before 0 is the answer. So the truth of the matter now is GCD of 57970 and 10,353 is equal to 17. That is the greatest common divisor. That is how to find it. Now let's go to the second question, number 2. Before I go back to the question, this is what happened actually. If GCD of A and B is equal to D, that is, if the greatest common divisor between two integer A and B is equal to D, the implication is that there exists M and N in Z, that is in the set of integers, such that AM plus BN is equal to D. Exactly. So this is a part of the definition. In fact, some textbooks use this as a definition of the greatest common divisor, while some use it as a theorem. So there exists two integers, that is, if you take any two number and the greatest common divisor is D, you can find two integers such that AM plus Bn will be equal to that greatest common divisor. That is what they want us to do in that second example. So that is why in the second example they say using your answer in 1. So in reality we are going to use what we obtained from 1. Express the two integers as a linear combination of their greatest common divisor. So I'm going to write these two things such that I will find two integers that I will use to multiply 57970 and also multiply 10353 in such a way that at the end of the day I will be able to write it as a linear combination of their GCD. Now let's get started. This is what we are going to do here. So we already know that GCD of 57970 and 10353 is equal to 17. Now look at what I'm going to do. I will be needing what I use above. To work. So I will start from down. This is the last before I obtain 0. This is what I have. This, do you understand? So see where I'm going to start from. This is from the division algorithm. I have 2057 is equal to 60 multiplied by 34 plus 17. So what do we do to that? We have we know that we know that 2057 is equal to 60 times 34 plus 17. So I will make 17 the subject of formula. Don't forget, 17 is the greatest common divisor. That is what I'm trying to do. Make 17 the subject. I have 2057 minus 60 times 34 is equal to 17. That is the first thing you need to do. Now, this one in the bracket 34. So look at what I'm going to do now. I'll go up again. I have written this. In fact, I have made 17 the subject. So the essence is that you will have to be making all the remainders the subject of formula. So, and what we are doing is that we will start from this down and we are going up. That is what we want to do. We want to start from here and go up like that. So I have written this 2057 equals 60 times 34 plus 17. So the next thing is make 34 the subject of formula. When you make 34 the subject of formula here, this is what you are going to obtain. In fact, maybe I should make everything the subject. Maybe I should make them subject of formula before I substitute. This one will be 4148 minus 2 times 2057 is equal to 34. As I have made the remainder the subject. So you will come up again. If you make the remainder the subject of formula here, this one will be, what you just need to do is that just be bring this to the other side, bring this to the other side. This one will give me 6205 minus 1 open bracket 4148 is equal to 2057. So you see what I'm doing? This is how to write it as a linear combination. Again, when you come to this one as well, make the remainder the subject. I have 10353 minus 1 multiplied by 6205. That will be equal to 4148. All these things I'm doing will be very useful. Don't worry, you will see how I'm going to be making use of them. Then I have come to the last one. This is 57970 minus 5 multiplied by 10353 is equal to 6205. Now we will start from down and go up. So I have already written this one. 2057 is equal to 60 times 34 plus 17. I have already made 17 the subject of formula down here. So I have 2057 minus 60 times 34 equals 17. So this is what I will do next. The next thing is 34. 34 is equal to 4148 minus 2 times 2057. That is the next thing I'm going to write. So look at where I'm going to do. You see this is 34 here. I'll substitute it. I have 2057 minus 60. Then the 34. According to what we have above, we have 4148 minus 2 times 2057 is equal to 17. So by the time you open this bracket, you have 2057 minus 60 times 4148 minus times minus will give me plus, then 60 times 2 will give me 120, then 2057 is equal to 17. So 2057 plus 120 times 2057, everything will give me 121 multiplied by 2057, then minus 60, 4148 is equal to 17. If you are not sure of yourself, you can press calculator for this, then press 121 times this minus 60 times this, and check whether you will obtain 17. So you will actually obtain 17, then that means you are on the right track, you are good to go. So after that, you go back up again. The next remainder, we have already used this is the next one we want to use. 2057 is equal to this 6205 minus 4148. 2057 is equal to 6205 minus 4148. So we will come here again. That is the next remainder we want to use. See, you will have to substitute this remainder. That's why we made them subject to formula. So anywhere you see 2057, put 6205 minus 4148. So we have to come here. So this is 2057. So we have 121. So 2057 is 6205 minus 1 open bracket 4148. That is what we have, minus 60 4148 is equal to 17. So 121 multiplied by this, that's 6205 minus 121 multiplied by this will still give me 121 4148 minus 60 4148 is equal to 17. So we have 121 6205 minus 121 minus 60 will give me minus 181 4148 is equal to 17. So when I get to this place, I will go to the next remainder again. So the next remainder that I made subject is 4148. 4148 is 10,353 minus 1 times 6205. I'll write it as well. So I have 121 6205 minus 181. So 4148 is 10353 minus 1 multiplied by 6205, and this is equal to 17. So 121 multiplied by 6205 minus 181 multiplied by 10353 plus 181 6205 is equal to 17. Now I'm going to add this together. 121 plus 181, this will give me 302. 302 multiplied by 6205 minus 181 10353 is equal to 17. Now the last thing to do is this one. So at the end of the day, I have 6205 to be equal to 57970 minus 5 times 10,353. So I will substitute this last remainder as well, and that will give me. So I have 302. 6205 is 57970 minus 5 multiplied by 10353 minus 181 10353 is equal to 17. So this will give me 302 57970 minus 302 times 5. 302 times 5 will give me 302 multiplied by 5 will give me 1510. 1510 10353 minus 181 10353, and that gives 17. So this is 302,57970 minus, so 1510 minus 181 minus 1510 minus 181 will give me minus 1691 multiplied by 10353 is equal to 17. So I'm done, since this is what I have. So how do I know I'm done? They want me to write um, these two as a linear combination of their greatest common divisor. So this is what we call the linear combination. So this is the, don't forget, we have GCD 57970 and 10353. This is the question, and we obtain the GCD to be equal to 17. So it means that we can write these two numbers as a linear combination such that the answer will be 17, and which is this particular answer we obtain, which is this particular answer we just obtained now, this particular answer. And what's the particular answer? It means that there exists 302, that's an integer, and minus 1691. That is what I was trying to define here. Before I started, I said here it is two integers. Here is this m and n such that am plus bn equal d. So it means, so those are the two integers we just obtained. Here is this 302 and minus 1691. Both of them are integers, such that 302 multiplied by 57970 and then minus 1691 multiplied by 10353 is equal to 17. So this is what they want me to obtain, and that is the answer. So this particular example look very cumbersome because of the high value given to us to obtain. But if we have relatively small numbers, it won't be as very bulky or cumbersome as this. I really hope you understand this. You can drop your comment in the comment section. Thank you very much.